Welcome to WD-TIE and USA Military Missiles Reviews, where we bring you in-depth analysis of the most advanced defense technologies from around the world, including the mightiest warships, cutting-edge fighter jets, and powerful missile systems. Today we take a deep dive into one of the most advanced and formidable aircraft carriers in naval history, the USS Gerald R. Ford CVN-78, a true symbol of American naval power and technological innovation in 2025. This colossal vessel is the lead ship of the Gerald R. Ford class of aircraft carriers and represents decades of engineering progress, new combat capabilities, and lessons learned from previous carrier operations. It stands as the United States Navy's crown jewel for projecting power at sea and ensuring maritime dominance in any theater of operations. The USS Gerald R. Ford was designed to replace the long-serving Nimitz-class carriers with a focus on greater efficiency, reduced manpower requirements, improved sortie rates, and enhanced survivability against modern threats. Measuring approximately 1,092 feet in length and displacing around 100,000 tons when fully loaded, this ship is essentially a floating city and a mobile airbase capable of supporting sustained air operations anywhere in the world. Its sheer size allows it to carry more aircraft, more fuel, more ammunition, and more supplies than most nations' entire navies combined. One of the most significant features of the Ford class is the implementation of the electromagnetic aircraft launch system, known as EMALS, replacing the traditional steam catapults found on Nimitz-class carriers. EMALS uses a linear induction motor to generate strong electromagnetic fields that smoothly accelerate aircraft to takeoff speed. This system reduces stress on airframes, allows for launching a wider variety of aircraft including lighter unmanned aerial vehicles, and provides more consistent launches in various environmental conditions. This technology also reduces maintenance requirements and allows for quicker launches, enabling the Ford to achieve a higher sortie generation rate than its predecessors. Complementing EMALS is the Advanced Arresting Gear or AAG, which replaces older hydraulic arresting systems. AAG provides a smoother and more controlled deceleration of landing aircraft, improving safety for pilots and enabling the recovery of a broader range of aircraft weights. Together, EMALS and AAG enhance the carrier's flexibility in supporting both manned and unmanned air operations, a crucial advantage in modern naval warfare where drones are playing an increasingly vital role, powering the USS Gerald R. Ford are two Bechtel A-1B nuclear reactors, each designed to produce significantly more electrical power than the previous A-4W reactors on the Nimitz class. This excess electrical capacity supports not only the advanced launch and recovery systems but also allows for future integration of energy-intensive weapons such as electromagnetic railguns and high-energy lasers. The reactors are designed for a 25-year operational life before refueling, giving the ship unmatched endurance and the ability to operate at high speeds for extended periods without the need to refuel at sea. The Ford class introduces a completely redesigned island structure, positioned further aft and slightly outboard compared to earlier carriers. This repositioning improves flight deck efficiency, allowing for more aircraft parking and smoother movement of aircraft during flight operations. The island itself features advanced radar and communications arrays, including the dual-band radar system, which combines X-band and S-band radar capabilities to provide both air search and missile defense functions. This integrated radar system reduces the number of separate radar antennas needed, lowering maintenance complexity and improving overall situational awareness. Crew comfort and efficiency were also major considerations in the Ford's design. Living quarters are more spacious, with improved climate control, better noise reduction, and modernized facilities. Automated systems throughout the ship, including advanced weapons handling and ammunition elevators, reduce the overall crew size compared to the Nimitz class, lowering operational costs over the ship's service life. These elevators, known as advanced weapons elevators, use magnetic motors to move ordnance quickly and safely from the magazines deep within the ship to the flight deck, improving rearming speed and reducing the time between sorties. In terms of air wing capability, the USS Gerald R. Ford can host a mix of F/A-18E/F Super Hornets, EA-18G Growlers, E-2D Advanced Hawkeyes, MH-60R/S Seahawk helicopters, and, increasingly, the F-35 Sea Lightning II stealth fighter. The deck is also being adapted for the MQ-25 Stingray unmanned aerial refueling system, which will greatly extend the range of the carrier's strike aircraft. With these platforms, the Ford can conduct a wide spectrum of missions including air superiority, strike warfare, electronic warfare, reconnaissance, anti-submarine warfare, and humanitarian assistance. Survivability is paramount for a ship of this importance. The Ford features improved armor protection, redundant critical systems, and advanced damage control technologies to keep the ship operational even under heavy attack. The ship's defenses include multiple layers, starting with its own air wing to intercept threats at long range, followed by the Aegis combat system on escort ships, and then close-in defenses on the carrier itself, such as the RIM-116 rolling airframe missile system and Phalanx close-in weapon system. These defenses are integrated with advanced sensors to ensure rapid detection and engagement of incoming threats. The Ford's design also anticipates future threats, with modular systems that can be upgraded throughout its decades of service. This future-proofing ensures that the ship can incorporate new weapons, sensors, and unmanned systems as they are developed. The large electrical power reserves, advanced command and control systems, and spacious internal layout all support this adaptability. In operational terms, the USS Gerald R. Ford offers the U.S. Navy the ability to project air power globally without reliance on foreign bases. It can carry out sustained operations for months at a time, moving rapidly from one theater to another. This capability is essential for responding to crises, deterring adversaries, and reassuring allies. In 2025, with global tensions and contested maritime regions, a ship like the Ford is a key instrument of U.S. foreign policy and military strategy. The cost of building and maintaining such a ship is substantial. The lead ship, CVN-78, came with a price tag exceeding $13 billion, not including the cost of its air wing. However, the Navy expects that over the ship's 50-year service life, the reduced crew size, lower maintenance needs, and improved efficiency will result in significant cost savings compared to the Nimitz class. Additionally, the strategic value of such a ship is difficult to measure purely in financial terms. Its presence alone can influence the decisions of adversaries and provide reassurance to partners and allies. From a technological standpoint, the Ford is a floating testbed for innovations that will shape the next generation of carriers. Its integration of digital systems, network sensors, and automation reflects the broader transformation of naval warfare toward greater reliance on information dominance and precision strike capability. The lessons learned from operating the Ford will inform the design of future carriers in this class, ensuring that each subsequent ship is even more capable and efficient. The USS Gerald R. Ford's journey to full operational capability has not been without challenges. New technologies like MLs, AAG, and advanced weapons elevators faced developmental delays and required extensive testing and refinement. Critics have pointed to these issues as evidence of cost overruns and program mismanagement. However, the Navy and its contractors have made steady progress in resolving these problems, and by 2025, the Ford is conducting regular deployments with improved reliability across its systems. Beyond its military role, the Ford also serves as a powerful tool for diplomacy and humanitarian missions. Aircraft carriers often participate in disaster relief operations, delivering supplies, medical assistance, and engineering support to areas affected by natural disasters. The Ford's capabilities in these areas, supported by its large deck space, helicopters, and logistics capacity, make it a valuable asset not just in conflict but in peacetime as well. For the sailors who serve aboard her, the Ford is both a workplace and a home. The improved living conditions, advanced training facilities, and modern amenities help boost morale and readiness. Life on a carrier is demanding, with round-the-clock operations, but the Ford's design reflects a recognition of the importance of crew well-being to overall mission success. As the United States continues to face challenges in the Indo-Pacific, the Arctic, and other strategic regions, the USS Gerald R. Ford will play a central role in maintaining freedom of navigation and supporting joint operations with allied navies. Its ability to integrate with other U.S. and allied assets, including destroyers, submarines, and land-based air power, makes it a cornerstone of modern naval task forces. In the coming years, we can expect to see the Ford participate in more multinational exercises, deterrence patrols, and forward deployments. Its advanced systems will be tested in realistic operational scenarios, and the data gathered will help refine tactics, techniques, and procedures for carrier operations in the 21st century. The USS Gerald R. Ford represents more than just a warship. It is a statement of technological leadership, industrial capability, and national W.